Good morning. This is homework help for chapter 5, and we're going to start with 5.3, number 23. Now, we're doing the integration here of this product, t to the 1/2 plus 1 times t plus 1. Now, in our integration rules, we don't have a product rule. We have we can use substitution, but we don't have a product rule. So what we're going to do here is we're going to FOIL this first. So this is a rewrite. This isn't any of the calculus yet. It's just the rewrite. Okay, and so I'm going to do first, so t to the 1/2 times t. Just a little side note over here, t to the 1/2 times t, we add those exponents. So that's going to be t to the 3/2. Okay, so I've got my first term is t to the 3/2. My last terms is t to the 1/2. My inner term is just t, and then my last is 1. Okay, and now that we have FOILed that, now we can find the antiderivative of each one of these. So we're going to have t to the 5/2, because I've added 1 to that, and 1 is going to be 2/2. Okay, and then we have to divide by our 5/2. Okay, and then t to the 3/2 divided by 3/2 plus t squared over 2 plus t, and then don't forget our c. We can do a little bit of cleanup here. Remember, when we are dividing by a fraction, that's multiplying by its reciprocal. So what we will have here is 2/5 t to the 5/2 plus 2/3 times t to the 3/2 plus t squared over 2 plus t plus c. Okay, and here we have it right here, and that's our final answer. Okay, now, so I think probably the confusion with this one is that you've got to do that multiplication before you can do any of our integration, is we have to do a rewrite. And so don't forget to do those rewrites. 25 is the same thing. We have to do a rewrite before we can find any antiderivatives or do the integration of that. So I'm going to rewrite this as x cubed over x squared plus 3x over x squared minus 4 over x squared, and then all of this dx. Okay, now I'm going to simplify that. So I'm going to have x plus 3 over x minus 4 over x squared. Okay, and I really can go, well, we'll go ahead and leave it like this. Just remember that this right here is x to the -2, because this is going to be, we can't use that rule for integration for that. So we're going to go ahead and find the antiderivatives here. So I have x squared over 2. Okay, this is going to be plus 3 times the natural log of x. So remember, 1 over x dx is the natural log of x. Okay, so this is going to be 3 times the natural log of x. Don't forget those absolute value signs right there. And then we're going to have minus 4x to the -1 over -1. Okay, so just remember, this x squared is x to the -2. We added 1 to that. That's how we get our -1, and then we divide by our -1. And then this is an indefinite integral, so we have to have our plus c. So my final answer to this is going to be x squared over 2 plus 3 times the natural log of the absolute value of x plus 4 over x plus c. And that is my final answer right here. Okay, and now we are going to move to section 4.4. 4.4. Okay, so now we have a definite integral, and what that means is that we don't have to have our plus c, and we have to do some evaluation. So first thing that we're going to do is we are going to find, there's no rewrite or anything that we need to do. We're just going to find the antiderivative of this. So I'm going to have x to the third over 3 minus x to the negative 1 over negative 1. Then we are going to do the evaluation of that from 1 to 2. Okay, so I've got to do 2 to the third over 3. We can rewrite, and so that's going to be plus right there. Let me do a rewrite first. Let me do a rewrite before we start evaluating. Okay, so I've got x to the third over 3, negative and negative make a positive, x to the negative 1 is 1 over x. We just want to make sure that we're not trying to do too many things at once, because that's when we make a mistake. So now let's do our, let's evaluate. So I've got 2 to the third over 3 plus 1 over 2. And then I am subtracting okay, then I am subtracting 1 to the third over 3 plus 1 over 1. Okay, 2 to the third is 8, so I have 8 thirds plus 1/2. Okay, now remember, we are subtracting both of these. So I am subtracting 1/3, and then I am subtracting 1. Okay, so don't forget to distribute that negative. Oftentimes students make mistakes with positive and negatives. Okay, so now I've got 8 thirds and minus 1/3. So that is going to give me 7 thirds. Okay, then I have 1/2 minus 1. That's going to give me negative 1/2. Okay, so now I'm going to go right over here. My common denominator is going to be 6, so that's going to be 14 over 6 minus 3 over 6. And so my final answer to this is going to be 11 over 6. Okay, and so this right here is number 21 on 5.4. And now we are going to do 29 on 5.4. 29 on 5.4. Okay. Now, this one is trig. Remember to have those trig derivatives and antiderivatives close by, because that will make this one easier. Okay, so we don't need to rewrite anything. What we do need to know is that negative cosecant squared of x dx is going to be cotangent of x. Okay, plus c. That's what this is something that you need to have on your formula sheet, and you'll be provided for that. So that's why you're looking for that. And so that right there might be where you got stuck on this one. So let's go ahead and take the antiderivative of this. So the antiderivative of 2 is going to be 2x. Okay, the antiderivative of this negative and the cosecant squared of x is cotangent of x. Okay, we do not need the plus c because this is a definite integral, and we are going to be evaluating this from pi over 4 to 3 pi over 4. Okay, now just a quick note about the unit circle. Okay, we are talking about pi over 4 right here, and then we are talking about 3 pi over 4. Okay, now the tangent of pi over 4 is going to be 1. Okay, so tangent of pi over 4 is 1. So the cotangent of pi over 4 is also 1. Okay, the tangent of 3 pi over 4 is going to be negative 1. And so the cotangent of 3 pi over 4 is also negative 1. Okay, so, and again, this trig might also have been where you might have made your mistake. So here, let's go ahead and do our evaluation here. So I'm going to have 2 times 3 pi over 4 plus the cotangent of 3 pi over 4. Okay, and we are subtracting. So then we subtract 2 times pi over 4 plus the cotangent of pi over 4. Okay, and pi is a constant. Okay, it's an irrational number, but it's still a constant. So we're going to keep working with that. So my 4's here cancel, or my 4 becomes a 2, and this 2 becomes a 1. And so then here we're left with 3 pi over 2. Okay, the cotangent of 3 pi over 4 is minus 1 because we are in the second quadrant right here. Okay, then I have minus pi over 2. Okay, and remember, we've got to distribute that negative sign. That's a place that's a very common mistake for students, is not distributing that minus sign. And then the cotangent of pi over 4 is going to be 1. Okay, so I have 3 pi over 2 minus 1 minus pi over 2 minus 1. Okay, 3 pi over 2 minus pi over 2 is going to leave me just with pi. And then I have minus 2. Now, this is my exact answer. And in general, we leave things exact. Okay, so don't keep going. This is my exact answer. And that's where we're going to hang out and stay. That's the exact answer. Okay, let's do number 37. Number 37. Sometimes with this one, students forget that they can do the rewrite. Okay, so don't forget you can do a rewrite here. And that's what we want to do before we do anything else, is a rewrite. So I'm going from 1 to e. And remember, e is a constant just like pi. Okay, so then I have t over t plus 1 over t dt. Okay, t over t is just 1. And then I have 1 over t dt. And now this is a little bit more straightforward for us to take our antiderivative. The antiderivative of 1 is going to be 1t. The antiderivative of 1 over t is going to be the natural log of the absolute value of t. And then we are going to evaluate that from 1 to e. Okay, so I'm going to put e in. So I'll have e plus the natural log of e. Okay, minus 1 plus the natural log of 1. And remember, we are subtracting both of those. The natural log of e is just 1, so you have to think back to those 112 log properties. Then I am subtracting 1, and I am subtracting the natural log of 1, but the natural log of 1 is 0. Okay, so my 1 minus 1 and my minus 0 leaves me with e. And that is my final answer right there. Okay, we have one more. Whoops, did I miss one in this section? I thought I had 3 in this section. Oh, I did. Okay, so we're good in this section.